As we know, three-phase systems, there are some balanced and unbalanced systems, and we have came to know the balanced system connections, and also how to just calculate some balanced three-phase AC circuits. There are probably three kind of connections, that is related to generator and the load. The Y to Y connection, Y to delta, delta to Y, and delta to delta connection. There is a generator part here, as you can see here. This part is generator, and this part is the impedance or a load part, and the currents has been generated from the generator to the load part. And there are three lines, as it is known as I have to find out the line currents in the three wire system, Y to Y system. This Y connection, this is also a Y connection. There is no neutral has been connected here, but the thing is that we have to keep on our mind that the phase voltages are equal to each other. All the phase voltages are equal to each other, and 120 degree apart, 0 to 41 minus 120. And there are three other loads, that loads are also equal, so that is quite a balanced system. So first of all, the three phase circuit in this figure is balanced, that I have told you. So we may replace it with its single phase equivalent circuit, uh, is shown here, figure 12.12, to obtain IA from a single phase analysis. Okay, first of all, they have told you to just go to the single phase system. So if we want to just find out IA, that means this line current, you need not to just make another single phase, just that is the line current IA. uh, the total resistance or impedance of this line current is 5 minus 2j plus 10 plus j8, as it is a series connection. So just adding up these two, you could find out the Z total. And after that, this Z total, and if you want to find out IA, as you know, that you can obtain it from Ohm's law. I is equal to V divided by Z T, Z or Y, maybe Y connection. So VAN, it means A to N, this neutral point, that means this 110 0 degree. So that will be divided by this. Now further, as you have to find out the zy. Zy is 5 minus z2 plus 10 plus j8, as it is in a series. So uh, the resultant will be this, and after you divide both the things, you can find out the line current. So that is the first line current. If you really find out the first line current, so as it is a balanced system, and you have to know which sequence is following here. If you find out a single line current, you can always you can you can find out another sequences too, because 6.81, this thing, that is pretty much important. 6.81, this magnitude will be same to the all line currents, because it is a balanced system. As it is a balanced system, a balanced system has similar phase voltages, similar load impedances, so they will get a similar current on each line. So how did you find out? First of all, you have to know that is a positive sequence or a negative sequence. As you know, the positive sequence is the ABC sequence, the negative sequence is the ACB sequence. As you previously know, that how you could find out the positive and negative sequence. First of all, it is a positive sequence. As you can know, as you know that in positive sequence, the line currents are also in positive sequence. 0 degree minus 240 minus 120 degree. Okay, so all things are 120 degree apart, that is A. After minus 120 degree, that will be in clockwise direction. Again the clockwise direction, minus 120, just adding up minus 120 to minus 120, you will get minus 240. So that is ABC sequence, and ABC means positive sequence. Now you have to just adding up your 120 degree. So here you can see that is minus 21.8 degree. You have to add minus 120 degree, and you will get minus 141.8 degree. After that there is a 240 degree. Just adding up this minus 240 to that, you can get 261.8 degree. Now you can easily understand that how you could find out the line current in YY sequence. That is one kind of practice, but you can also find out the phase voltages, line voltages, all of the voltages you can also find out. We will understand now. Just look at the point, practice problem 2.12.2. A Y connected balanced three phase generator with an impedance of zero point 0.4 and plus j 0.3 ohm per phase is connected to a Y connected balanced load with an impedance of 24 plus j 19 ohm per phase. First of all, look at it. Per phase is stated here, okay, and there is a Y connected balance, that means balanced load. So balanced load means zy will be equal to all the three phases. So you have to add these two as it is in series connection. Okay, in previous mathematics, these two mathematics has the same figure. Okay, so you have to add up these two things and you can easily find out zy. That will be 0.4 plus j 0.3, that will be adding up to this 24 plus j 19 ohm. By adding these two you can easily find out zy. Okay, after that the line joining the generator and the load has an impedance 0.6 plus 0.7 j ohm, that means the line impedance. So you can also add up this impedance too. All the impedance should have to be added as it is in series, that is known as per phase. So all things will be adding like this. After adding these two, adding these three impedances, first of all that is the generator load, second that is the load of that is the balance load with impedance, and that is the line, the impedance of the line. So all the things will be adding up. That means the ZZ generator load, ZL the line load, and Z capital L, that means the impedance of the real load. So after adding up these things you can easily get ZY. Okay, now coming back to the point that there is assuming a positive sequence. Positive sequence means ABC sequence, A, B and C sequence, A, B, C sequence. So you have to go on top and find out that what is the positive sequence states. As you can see here, I can also show you the positive sequence is like that: VAN, VBN, VCN. 0 VBN will be minus 120 and VCN will be plus 120. That is the positive sequence you have to keep on your mind while calculating any kind of mathematics. So there is a phase voltage, as it is AN, so it is a phase voltage. Phase to neutral means it is a phase voltage, okay, in Y connection, and 120 degree 30 volt. Find the line voltages first of all, then the line current. Okay, that will be find how you can find out these things. Okay, let's do in another lecture.